So,
okay, so
right. Well, first of all, thank you very much for having me, and it's really a pleasure to talk about PyHEP, the working group, and the workshop. So I'll be discussing on behalf of myself, Ben, and Jim for the convenience. Okay, so Python, in spite of being maybe obvious for many, I still have a couple of interesting plots to show you here, even if you are totally convinced. Starting with this one from the popularity of Python programming languages website. Links are there. In general, there's quite a few links in pictures, by the way. And you can see that Python really is dominating quite strongly, especially in terms of numbers. Don't forget that this is actually a logarithmic scale. And the growth of Python has been quite big over the last few years. And the same conclusion you can have if you actually look at the same popularity, but for machine learning from a machine learning perspective. So why? There's very different reasons. For sure, the big one is that there's a very large software ecosystem built atop NumPy and SciPy, with really a quite large and active community. And not the least, there's excellent documentation and community support. Typically, if you have a question, either you immediately find it on Stack Overflow, or else you can actually get the answer to your problem very quickly as well. So if you look more specifically at particle physicists and why you use Python, this is in fact one of the plots that we have here from the pre-workshop survey. So first of all, you know, in the statistics we have over 400 people, so this is not, it provides us some nice statistics for doing this, and you can see here some popular trends. So in particular, the interest from Python comes from the availability of general purpose data analysis tools, and also machine learning and deep learning toolkits. So in short, tools for data science, for big data. You can also see next to it, there's the availability of other tools for particle physics, either root or non-root. See, actually, there's a fair share there, and also you have one of the main reasons is still is development speed and efficiency. So this is something we're actually seen across the various surveys we've done in the workshops. It's a constancy. What is not a constant is actually the growth of Python usage in particle physics. So if you go a bit more specific to us, we have a couple of surveys that have been done, quite nice. So for example, this one from Jim on CMS, where he profits from the fact that the CMS software stack is available on GitHub since quite a few years now. So if he examined in particular the non-forked repositories, so pretty much user repositories, code that is prepared for analysis and everyday work. In terms of statistics, you see there's a huge amount of such repositories from which you can get then the plot on the right. And again, you see a very clear trend of Python going up, whereas C++ is going down. And in fact, the crossover was sometime last year already. And by the way, if you also look at the third curve there in green, which means for Jupyter, typically that's actually Python notebook. So again, the trend is pretty obvious for the growing popularity of Python. On the LHCb side, so this is something that I had looked into it, and also Hans Dębinski for the root users workshop. And this was already 2 years ago. You can see, for example, from the plot there, the usage of root from standard macros or Python, and there was already 2 years ago a fair share, kind of 50-50 share of the popularity, and this has only swapped into a more popular usage of Python in the meantime. This is also something that I did there in a very long, extensive analysis survey report also in 2018. So this is just for the introduction, and I'll spend some time on the HSF, the PyHEP working group, and then quite a bit on the series of workshops actually, and some community projects as well, as you know, on the fly. So starting with the working group, so this is something that we started now almost 3 years ago, early 2018, and the idea this time was to prepare the first PyHEP workshop that was held as a pre-CHEP event in Sofia. So and in the meantime, so notably because of the popularity, then the activity group became a formal working group in the same way that you have a few here shown from this snapshot of the HSF website. So you can see the activities groups and the working groups with PyHEP highlighted. So of course we do in particular meetings and workshops and events. And this is actually of course the PyHEP workshops. So in terms of activities, first of all, it's very important to realize that what the PyHEP working group is trying to do is really bring together a community of developers and users for particle physics at large, and try to embrace a broad community, not just HEP again, but also astroparticle intensive frontiers. And we just had this presentation from nuclear physicists, and this would be a very nice addition to have. So maybe not, this is maybe not exemplified in the affiliations of the coordinators, but we see from the pie charts of the attendance in the workshops that actually there's a very broad community indeed. So here there's a snapshot of various bits of information on how to get connected. The main one is the main means of communication is the GitHub channel PyHEP. You see that we have now over 150 people registered, quite nice, and we have a few other ones that are more topical, such as Instagramming, also new cameras and so on. So you're very free to register for that. And you see again, there's links on almost every snapshot, so you can navigate through it very quickly. I mentioned community is important, so and you probably know already this citation from Gordon Watts, so how we tackle these following issues, and this is pretty obvious. We have been discussing this in HSF workshops in particular for quite some time, so I won't relist them explicitly here, but there's quite a few challenges, and we really should tackle them as a community. And so this, and again, the working group is a way of tackling these things for what concerns Python specifically, of course. So there's many topics, but you know, it is a way to exchange information in material experiences and so on. It also has an educative component, and there we have a link with the training working group, something that we actually are quite keen to re-emphasize in the future. So it should also not come as a big surprise that all over the last 2-3 years there have been various community projects started. And these are the bigger ones in terms of probably a popularity, also of commitment and number of packages that are provided for the community by the community, because it's in the end are users just as everybody else here. So you can see there's quite a few. And again, I give you the links if you want to follow up. Okay, so the rest of the presentation, I'll focus on the workshops. First of all, so you know, if you wanted to bring up a community, then of course a workshop is an obvious way of doing that. I mentioned that the first one was done in 2018, and then we had another one last year. And you see from this pie chart, it's pretty clear that we had a very broad community. Yes, there is a big chunk, a big fraction of people coming from the big experiments of the LHC, but you see in particular that 14% every time actually of the participants came from IT groups at labs or universities. So this was excellent to see. And we also had a small level, fair enough, but we also had quite a few participants from all kinds of experiments, being the Trinity physics, astronomy, and so on. I won't go into this, but this was a snapshot of the reasons for the workshop. At the time, these things have not changed very much. You still want to bring together users and developers and have lively discussions in the workshop. So we have roughly a third of the time devoted to discussions all the time. So focusing now on the workshop this year. So this was a special one for various reasons. And I'll mention a few things on organizational aspects and also highlight some bits. If you want, there's a far more information in the backup slides. I will leave it to that, but of course that will take probably well over half an hour to go through. So it's all in the backup. Okay, so it's a special cuvée. Well, because this year has been special, it started off nicely, and we had, okay, we went on, we started preparing this thing, we made a nice flashy poster, we connected with the SciPy community. So this is a big conference happening every year in Austin, in Texas. We discussed with them to really engage. That worked pretty well, but of course at some point everybody went virtual, but that was not negative in all reasons. And the really positive thing here we should stress is that then we could really go for a truly global event. And that is reflected in the number of participations. You see that we had avoided 50-70 participants in the face-to-face meetings in the previous years, are either as pre-CHEP or and then in the UK, and then all of a sudden we had a huge interest, and we had to limit participation actually at 1,000 registrations. So this snapshot is, again, there's a few links to the main page if you want, but I just wanted to highlight here the sponsors. We had quite a bit of interest as well. and that's reflected in the number of sponsorships that we got. So PyHEP, University of Liverpool, the UK Software Sustainability Institute, Fermilab for Zoom, and also the Python Software Foundation that has been supporting us since the beginning. Okay, so this is a big slide, but actually it conveys a summary of everything that went through in the workshop. So I'll go through properly. So first of all, we used Zoom as a video conferencing system, and that was a way to be able to cope with potentially 1,000 participants simultaneously. And we had Slack channels for communication. We had various ones. First of all, we had a few per topic. So every topic of the workshop sessions had a dedicated Slack channel, and also had a few other ones, general ones for announcements, or even a random one to encourage people to discuss and have some kind of social exchange. That worked pretty well, I have to say. As far as the sessions and the presentations are concerned, so the first thing we did to try and be global was to have sessions spread across the 5 days, but in two friendly zones, so Atlantic and Pacific zones, 3 hours for the Atlantic sessions and 1.5 hours typically for the Pacific sessions. We strongly encouraged every speaker to have a notebook presentation with the notebooks available publicly on the GitHub repository with the binder launch button. And this was to make it as easy as possible for everybody to actually dynamically play with the presentation. They had a lot of interactive materials, as you can imagine. So all the presentational material was posted on the agenda, being a standard PDF talk or a notebook. Later we attached a digital object identifier DOI on Zenodo via dedicated community there. So you have all the links, and then she also mentioned that all the talks were not only recorded but also captioned and then saved onto or uploaded to YouTube on the HSF channel, again dedicated on the PyHEP dedicated list. And as far as the questions and answers are concerned, this also tried something new, and that was with Slido. So this is a nice way of crowdsourcing the questions, in the sense that anybody can type some questions on the platform, and then click on the thumbs up or thumbs down to upvote questions. And of course, given the limited time you have typically 10 minutes for discussions in between presentations, we then could discuss live the most popular questions, and then everything else was downloaded or put on the topical Slack channels for the discussions to continue offline, and for everybody to have the opportunity, particularly for the speakers, to have the opportunity to reply to the remaining questions that could not be answered during these 10 minutes. That also worked pretty well. We also ran a few polls, and that was one. Last thing is that we had a live communication on Twitter, and I think this was one of the reasons why we had so many participants, because the advertisement was quite effective through Twitter. So I'll give you a few highlights now on this. First of all, just to mention, as far as the workshop agenda is concerned, we had 2 keynotes, one from astronomy and one from a flavor physics theorist. And we had quite a few tutorials, which were typically 45 minutes. So that's why the difference between the topic, a standard presentation of 20 minutes plus 10 with respect to a tutorial that was much longer. It was more educational. And you see that clicking between the two, there's a fair share, kind of 2/3, 1/3 for talks and tutorials. You have the list for your own inspection if you want. I mentioned Binder for the presentation, so let me say something we were so we really strongly advised everybody to try and make it all available on Binder. But of course, we wanted participants to have a smooth participation. Hence, we got in touch with the Binder Federation to have allocated resources on time for every given repository for the relevant presentation. And I'll have a statistics that really shows you nicely. So no wonder that Binder was actually one of the leitmotifs of the workshop. By the way, the fact that you have Binder with Zenodo also allows you to get some, so to speak, a live workshop proceedings. Because given a Zenodo DOI, you can actually launch anything from Binder. This is maybe something that's not so widely known. So this cute plot here in blue and orange shows you the number of participants versus the number in orange of Binder requests per hour. And you can see there's a perfectly nice match between the presentations, the participants on Zoom and the launches. Of course, you have less launches, but things, see that the participants were really playing the game and trying to run through the notebooks at the same time as the presentations were ongoing. We also had
Eduardo, you have 5 minutes left.
No problem. Okay. As I mentioned, we had more participants from Atlantic sessions than Pacific ones, and this is an important feedback that we have to take into account for the future. Just to show how things were looking on Slido for the questions and answer session. So on the left, you have the kind of questions that you might put, and then you also had, as I mentioned, some polls. We had a few of them, and this is the result of one of the polls that we could then display for everybody. In terms of diversity, this is a world map just to show that we did have indeed participants from all over, just about every corner on the planet. And this is taken from the pre-workshop survey, where, as a reminder, we had over 400 responses. In terms of diversity and inclusion, this plot is not quite as the same as in the previous years. If you look at Atlas, CMS, and LHCb, this is pretty much the same. Same for here. We had many participants from all kinds of smaller, not so small in the case of June, but for small experiments. But the big difference is that we had basically 40% that mentioned this other or no experiment. And this, if you look at it, it's basically undergrads and people working in theories, instrumentation, and simulation. There was a fair amount of participation from there, and this was really great to see as well. In terms of highlights, so this is my final slides. This is a word cloud of abstracts. The topics are there, so analysis fundamentals, analysis platform systems, automatic differentiation, performance, fitting and statistics, and analysis ecosystem in general. As far as the two keynote presentations are concerned, we had very interesting presentations. One of the things that to come back to my previous slides, first slides, is to show the relevance of Python across the recent years, be it in phenomenology, in hydrogen physics, or in astronomy. You see again, Python is growing, not the only one, but it's clearly a big player. And my almost final slide is on one of the trends that we saw from the workshop. It was on auto differentiation. We actually had a tutorial on that and also a standard presentation. So I invite you to have a look at this, and I suspect that we will have more and more interest in these things. And in fact, we would like to have one of the topical meetings from the working group in 2021 dedicated to auto differentiation. So in summary, I just want to thank you for listening. I'll give you a few links on how to connect with us, and by all means stay tuned and engage with us for the next PyHEP workshop in 2021, as well as several topical meetings that we are currently preparing. Thank you.
Okay, thank you, Eduardo, and thank you again for this very nice talk and very complete overview of the activity and for keeping on time. So I see a few comments in the notebook. Maybe Paolo, you may want to start, as it is a transition from the last word, Eduardo.
Yeah, but my question is on the chat. I was wondering, given how successful it was, if PyHEP 2021 is going to be all at home as well. Or...
yes, I forgot to say that. Yes, so 2021 will for sure be a topic, will be virtual. And we still want to try and connect in the best way possible with SciPy, because we thought it was in spite of all the circumstances, was still important. We actually had, I think, 4 or 5 presentations from HEP at SciPy itself. And so we want to continue on that for the future, where we will at some point be able to have some face-to-face meetings, but that will not be in 2021.
Okay, so maybe TG, you had also a question in the live book. Do you want to ask it?
Sure, thanks. Right, so this is maybe a difficult question to answer quantitatively, but with bearing in mind what you showed, Jim's statistics of the CMS growth of Python-based repositories, I was wondering if you have an estimate of how many actual published analyses, sort of what fraction of them have been produced primarily in Python. So by this I mean more than just a few PyRoot scripts processing the output of C++ code. And then similarly, how much has been produced with Jupyter?
Yes, so it is, as you can imagine, a very difficult answer. I know a few examples. I think this is something that we should try and quantify. I can tell there's a handful for sure. I'm absolutely, I know of, maybe there's far more that I'm not just unaware of. So that's something we have to survey at some point. The problem very often is that unless you are exposed to it yourself, you know that we're not very good at recognizing software work. So in principle, an easy way to do this study, it was simply would be to scan the publications and see immediately what packages are being, or big packages are being cited. Unfortunately, I can tell from LHB there's been a struggle, and it's very often you hardly see any Python package being cited, in spite of the analysis of cases that I know of having been done with the data science tools, channel tools. I know a few, yeah. I suspect there's quite a few more in CMS, but numbers, I think I take your point. This is a very interesting thing that we would like to quantify.
Okay, may I have a very quick follow-up, which is, given what you said about citations, should we be, in HSF, be pushing, especially experimental collaborations, to be better about citation of exactly the packages and tools that are being used to produce results?
Totally. So sorry for the personal advertisement, but I did actually give such a presentation to LHB already on behalf of the HSF. It was reasonably well received, and I would say that things have improved since then, but as often it is a slow, things improve at a slow pace. So I think by all means, this is something where we can have some influence, and now that the HSF is much more widely known and taken on board, I think we will, if we restart that discussion, it will probably have a bigger impact. It's a good point.
Maybe on the same lines, there was a comment by Ben. It was about how many, do you know about how many packages across a GP are written in pure Python compared to binding to another language like C, C++? Do you want to comment on this?
Yeah. So in this community project I mentioned earlier, give me a second. I think roughly speaking, mainly used, there's over 20 by now. At least 2/3 are pure Python. I think I don't think precise numbers matter, but roughly. So we're talking about anywhere 15 packages that are pure Python, and some other ones are bindings actually.
Okay, thanks. Liz, you raise your hand. Liz?
Sorry, I had to find the button. Yeah, I guess I have a question just based on, the fact that, 1,000 people registered and 200 showed up. How do we know that we got the right 200, because I think we did actually have to stop taking new registrations. So do you have any feel for that?
So the big number we got was in the first session. We topped at 430 people at the same time, and then you went down indeed to something around 200, 300 there. No, it's actually quite difficult to know even from the surveys why did people, why not everybody was attending. I think it's probably safe to say that overall at any point, integrating, there was probably a few more than 500 people attending some part of it. But I suspect, given that it became all of a sudden very popular, was tweeted and so on, I think many people just said, oh, there's no registration fees, it's all online, let me register just in case. We actually got a few feedback from people that apologize, even saying, oh, in the end, I can't attend. And we even managed to give access to 2-3 participants that were above the 1,000 in the meantime. But it's I don't know how to do this.
Yeah. So do you know how many people, after you gave the 3 access, were still on the list?
I'm pretty sure. In fact, for meaning that they attended.
Well, no, I mean people that we had to turn away.
No, no information on that.
Okay.
No.
Could I add at this point that the number of people who complained about the limit of 1,000 was only 1 or 2. It was a small number of people who emailed us asking for that to be let through. But as for the number of people who tried, couldn't get in, and didn't say anything, we don't know.
Yeah.
I see.
But we will play the game this is something we already discussed slightly for next year, is to leave it open and try to see how things progress. We also had the suggestion, but if you apply a very small registration fee, all of a sudden you'll probably twist towards having people that actually really want to attend and are likely to attend. But that's not quite what we see even in for physics conferences, where we have 1,000 people registered and then only 200, 300 attending. So it's a very difficult problem. Yeah, I don't really have a solution. Sorry.
And I just dropped this in the chat, but I'll say it just further. I mean, we have thought as well about for the next year, if we can set up live streaming, then the physical, the limitation really was the number of people that could join the Zoom room. So we can probably find technical ways around it, and then there's no reason to have a hard cap on how many people can subscribe at that point.
Maybe a last question before closing. Ben, you had a remark about Python in DAQ simulation and other use cases.
Yes, I mean it's maybe my well, I'm not sort of totally up on the Python adoption, but it was really that it seems to be very widespread and used for analysis at the moment. But I wondered about the uptake in other areas of HEP computing, such as simulation or DAQ or data transfer management and things like that. And is it an appropriate tool for those? And if so, how to encourage and promote it in those areas?
Maybe other people want to comment, but for example, the rack system for distributed computing is a Python. Is a complete Python framework. That's what we use to submit jobs to the grid effectively. Also via Gang, which is another thing we have in LHB, which is again is pure Python. So there are a few places where you can have pure Python software. I wouldn't go as far as saying that this is appropriate for everything. Of course, I think we have to be quite honest that just as any programming language, it's got its scope as well, right? We shouldn't go just widely for the sake of it because it's super popular. You apply it to a random area.
Mm-hmm. Right. That's great. Thanks.
Thank you. I don't know if there is another question.